Hello students. Now we will, previously we had seen the practicals based on the DC motor. Okay, there was armature control method, field control method. Okay, so now we will see the field control of DC motor by Ward Leonard method. Okay, so what does it mean exactly, Ward Leonard method, and what will be the results? So in that we are going to make armature will be the speed of motor. Means if suppose we are changing to sorry, we are varying some voltage, that time what will be my speed of motor? So that we are going to check. Okay. So let us start this with the theory part, and then we'll go for the free test as well as procedure. So as we know that in a Ward Leonard method, whatever be the speed is there, that speed can be controlled by varying the applied voltage, by varying the applied voltage to the armature. Okay. So in this method, we know that there is a one mg set. Okay. So we can say in that the whatever be the separately excited DC generator, that has to be driven by the three-phase induction. So the combination of this AC driving motor and the DC generator, that is again known as a motor generator set, or I can say it as a MG set. It is known as a MG. So in theoretical part, as we know that the speed control by varying armature resistance, as well as we had understood that the equation is about N is equal to V minus IRA by K5. So in such cases, as we are going to understand about the whatever the Lord Leonard system. So in that system, we are simply going to use a two. Means a we can say there will be a one mg set. This side you can say this is mg set. Another one will be the motor whose speed is going to control. Okay, so now whatever be this three-phase supply induction motor is there, it is a constant speed motor. Okay, this is a constant speed three-phase induction motor. That is, means whatever be the generator is there, that generator will be driven by the this generator is driven by the induction motor. This motor is a constant speed motor. Okay, so why this system has been adopted? Because as we know that there are many reversal operations. So in that reversal operation of the motor, at that time by changing the polarity of voltage which are applied to the armature. So this condition can be achieved by only reversing the direction of field current. So with whose direction of whose field current, that field current should be a separately excited DC generator. Okay. So in that one, Leonard, if suppose we consider that a constant voltage DC power which is not available at that time, suppose whatever be the constant voltage excited that is coupled with the MG set, then whatever be the direction of the current, that will get reversed. So in which manner? So it will be get reversed in a first, that is by providing the reversing switch in the field, and the next, that is by connecting a two potentiometer revested across the generator field across the motor. Okay, so this is all about the means basics of the we can say means this Ward Leonard method. So what is expected, that you can see the armature voltage and speed graph. Okay, and some theoretical advantage, disadvantage has been given. You can read that. So let us go for the procedure, and we'll go for the working. Exactly how it performance for this. So that we will see in this simulation. Here you can see the instructions. Okay, so let us check. This is the instruction. First, connect points A1, B1, C1 of MCB to input points A2, B2, C2 of auto transformer. Clear? So let us go. That A1 will be connected to the A2, B1, B2, and C1, C2. So from main to this, it has come here. Now from auto transformer, it will go where? We will check. Connect outputs from E1, F1, G1 of auto transformer to points E2, F2, G2 of induction motor. So from this to this, and again that F1 should be connected to F, then G1 to the G2, then connect D1 of DC supply with point D2 of starter. So the D1 DC supply should be starter. Then connect the point K1 of DC supply with points M1. So that should be connected to the M1. So here you can see whatever be the K1 point is there. See, whatever be the K1, that is a point of DC supply with points of M1, K2 of DC generator, and point L1 of DC motor. Okay, so let us start. Let us connect first point, that is D1 to DC. We have already connected. Then D1 of DC with D2 of starter. Then connect K1 of DC supply with points M1. So K1, that should be connected to the M1 first. Then K2 of DC generator. So again from here I will take it to the K2 of DC generator. Then again point L1 of DC motor. So you can see here is the AC motor. So I will connect that to the L1 of a DC motor. Okay. Now connect point H1 of starter with point H2 of rheostat. Okay. So that H1 should be connected to the H2. Okay. And I1 of DC motor. This H1 should be connected to the I1 also. Then connect J1 of starter with point J2 of voltmeter. Then J1 should be connected to the J2. Then and with point I2 of DC generator. So this J1 should be connected with the I2 also of the generator. Okay. Then we'll come. Now we are at the step number 5. Connect point I2 of DC generator with point M2 of DC motor. So I2 M2 should be shorted. Okay. Then connect point M1 of DC generator with point N1 of DC motor. So this M1 and N1 will be shorted. Okay. Then connect point N2 of DC generator with point O1 of rheostat. N2 to O1. So this N2 and O1 will get connected. Now almost connections are done. So only the voltmeter negative is pending. So let us go for the 6th step. So that step number 6, connect point L1 of motor. Okay. So connect point L1 of DC motor with L2 of voltmeter. So this L1 and L2 will be connected here. Okay. Connect point L2 of voltmeter with point M1 of DC generator. Okay. So connect point L2 of voltmeter with point M1 of DC generator. So this will be connected to this M1 also. Step number 7 is to check the connection. So I'll click on the check connection and there is error. Correct connection process to take reading. So somewhere it is having some error. So let us go back and I'll click on this. Let me just enable. Okay. So I'll just take one step back and then we'll go for the simulation. Okay. So means parallelly we will open 2 pages and I'll click on this simulation page. Okay. Here will be simulation page and the left one will be our that page, right? So I'll make connections easy, right? So now see, first connect points A1, B1, C1 of MCB to the points in A2, B2, C2 of auto transformer. So A1 to A2, B1, B2, C1, C2. Again I need to reset A1, A2. This is the drawback of virtual LAN. If you miss the one connection properly, then it take you to back. Then connect output points E1, F1, G1 of auto transformer to the E2, F2, G2. So from auto transformer we need to go for the induction motor. E2, F1, F2, G1, G2. That is the connections of the induction motor. Connect point D1 of DC supply with point D2 of starter. DC supply D1 connected with the D2 of DC starter. These two. Then K1 of DC supply with K1 of DC supply with point M1. Okay, K1 of DC supply with point M1, K2 of DC generator and point L1. So K1 should be connected M1, K2 and L1. M1, K2, L1. M1, K2 and L1. M1, K2, L1. Okay. Then connect H1 of starter with point H2. H1 to H2. That H1 should be connected to the H2 where it is here. Okay. Of DC generator filters and I1 of DC motor. So this H1 should be connected to the I1 also. Here also. Okay. Connect J1 of starter with point J2 of voltmeter. J1, J2. So that will be here. And with point I2 of DC generator. So that J1 to I2. J1 to I2. That is very simple. Okay. Then step number 5 will come. Step number 5. Connect I2 of DC generator with point M2. So I2 M2 should be shorted generator I2 motor M2. So that I2 M2 that is connected. Okay. Then M1 of DC generator with N1 of DC motor. M1 N1. So this M1 N1. Okay. So simple connections. N2 of DC generator with O1 of DC generator field resistance. N2 of DC generator where it is here. It is connected to this. Okay. I hope it is clear till now. No one have any doubt. Okay. So then next is L1 of DC motor with L2 of voltmeter. So L1 to L2. That is again here clear connection. And that L2 of voltmeter with point of L1 here also. That is coming back. Okay. So if the wire is a maze, click the node number to discharge. See A1, A2, B1, B2, C1, C2. Okay. Here you can cross check A1, B1, C1, A2, B2, C2. See A1, B1, C1, A2, B2, C2. Fine. Then D1, E1, D1, D2, D, E, F, A, B, C, D, E, F, D, E, F. So D, E, F, D1, D2, E, E1, E2, F2, G1, G2. H1, H2, H1, I1. H1, H2, H1, I1. H1, H2 and H1, I1. Okay, fine. Here, J1, I2. Check. J1, I2. It is fine. K1, K2, K1, L1. K1, K2, K1, L1. K1, K2, K1, L1 and K1, M1. L1, L2, L2, M1. L1 that is L1, L2, L1, K1. Okay. And here M1, N1, L2, O1. M1, L1. Okay, I will check the connection. Again, it is somewhere in this. Let me clearly check. This L2, M1. See, L1 is to L2 and L2, M1. L1 is to L2 and L2 is to M1. K1, M1. K1 to the M1. It is fine. I2, M2. Where it is I2, M2. It is again fine. M1, N1. M1, N1. M1, N1. N2, O1. N2, O1. N2, O1. So now according to me all the connections are still it is showing somewhere error. Let us see. Just a minute. Okay, now you can see the corrections are okay. So now you can see, however, we need to check our voltage is decreasing or speed should be decreased. So let us click on this on. So this is on. Okay, now double click on this auto transformer. Okay, so this transformer automatically come to this. Okay, then what we will do, we'll change this speed. Okay, see it is started, and I will take a reading, add values. Then next I'll again add, and at that time also I'll add values. Again I'll take one more reading, I'll add values. I'll again take one reading, I'll click on add values. Okay, means you can add values, means you are adding armature resistance. Okay, and adding values. Okay, I'll click on more. You can also observe the speed. I can click on more, so that will again add values. Okay, so this is all about the readings which I have taken, and once you have taken the readings, automatically that graph will be here. You can see here also. See, automatically graph will be there. Okay, so once graph is there, you can click on the print this page, and you will get the whole details of this practical in a single print. Okay, so let me check it is in proper page. Yes, now it is in proper page, and you can see here, you can, okay. Just a second. Yes, it is now. I'll save it to the same. Yeah, I'll write here Ward Leonard speed control system, or speed control of PC motor. That is the practical. Okay, so let us have a look on, you can photos you can from, and you can have post staged. Okay, you can check references and all that things. Okay, this is all about the Ward Leonard method of the speed control DC, sorry, DC motor. Thank you.